Hello and welcome to your third lecture for Java Programming 1 CIS 1500. Today is the 21st, so we're in the week of the 20th, and we're starting on Chapter 2, which is the Java Fundamentals. Next week you will have a programming project assigned. The programming project, again, for anyone who came late to the course or hasn't paid much attention, it will be under Assessments, Dropbox. The content for the course, including the slides and also links to the lectures once I've completed them, are under Content. So Lecture 2 was uploaded. It's actually Lecture 1 and 2 from last week because we had the snowstorm and the polar vortex occurred, and it caused us all kinds of problems. So I completed the material from the last 2 weeks and last week, and then this week we're going to start on Chapter 2, and we'll complete Chapter 2 next week. Chapter 2 is quite a large chapter. It does have a lot of material. I'll be using the slides to just stay on track, but we're not going to complete all the slides today, so we won't need all 95 slides in one sitting. But Chapter 2 is Java Fundamentals. Again, this is from the starting out with Java from Control Structures Through Objects 5th edition by Tony Gaddis. The chapter topics are the parts of the Java program. So what makes up a Java program? The print and print line or print len methods, depending on who you hear say it. I just usually say print line. But you'll have to remember it's print ln, and you don't spell line out. These methods are important, and how they relate to the Java Application Programmer's Interface, or API. Variables and literals, primitive data types, arithmetic operators, and we'll pretty much stop at that, section 2.5 today. But we will continue next week with combined assignment operators, creating name constants with final keyword. The string class, we'll talk about scopes, more on comments, programming style, using the scanner class for input, and dialog boxes. So, a Java source code file contains one or more Java classes. If more than one class is in the source file, only one of them may be public. So you can only have one public class within a particular source file. The public class and the file name of the source file must match. For example, if you have a class named simple, it must be in a file named simple.java. Each Java class can be separated into parts. All right, so we can create a project here to house this. This was our test from another time. Let me create another file or another project by going to File. I'm in Eclipse, by the way, so I go to File, New, Java Project, and this one we're going to call Lecture 3 Examples. Okay. Hit Next. And finish. Then I have an empty Lecture 3 examples here on the source file, source folder. I'm going to right click, go to New Class, and for one example, we're going to make simple.java. Oh, sorry, just write simple. You're not supposed to qualify the name. The package, again, you should use like a meaningful package name. So com.prof.jpbaugh .lecture .simple. For this particular class, it's good to make the last one equivalent to the class name, but in all lowercase. And we're going to hit finish. So this gives me the basic outline of my class here. It's empty right now. I have public class simple keywords, and then an open curly brace. The curly braces are on the keys directly to the right of the P. So you've got the curly brace and then the square bracket underneath. You have to hold down Shift and hit the open curly brace, and then Shift to do the closed curly brace. In Java, anytime you have an open curly brace, you should have a closing curly brace to match somewhere else. So simple.java, what they have in this particular code, if you look at page 29 in the book or click on the link in the slide, I believe it goes to a website, but I'm not 100% sure. Let me run this real quick and see what it does. Okay. Guess not. Okay. Well, that probably was located somewhere in some of the downloadable files. I could get that to anyone, but I would rather you guys type it out, to be honest, to get used to it. I prefer, especially if they're smaller, I prefer typing them out myself. But you have system.out.println. Programming is great fun. Okay, we can put pretty much anything in there. What's it complaining about? System.out print line. I think we're missing something. Oh, I'm an idiot. Okay, sorry. Public. I knew I forgot something. Public static void main string args. There we go. Has to be inside of a method. I don't know what possessed me to just start typing, but I saw curly braces and got excited. Okay, so the main method is actually the first method called the entry point. That's when you first have a when you first execute or run a program. The main method is the method where everything will start. Now this has the public keyword also. It has static void and then the keyword main, or not keyword, but the word main for the identifier of this class's entry point. And then for a parameter, the argument string, open and close square brackets, args for arguments, and then inside of here we have system.out.println. Programming is great fun. Okay, so you could compile using the command line. If you use the command line, that's where you go to start and then find command line or command prompt, and you could run Java C if you have the paths set up and everything. But we have our everything set in our Eclipse environment. You could also do this similar thing with JGrasp as well. But just so you know, if you are compiling utilizing the command line, then you want to use Java C, which is the name of the Java compiler. You have to have the Java Developers Kit installed for this to be available to you. You can't just have the Java runtime environment. You absolutely have to have the Java Developers Kit, because if it's just the runtime environment, that's just so anyone can play it, so the JRE. But if you're developing in Java, meaning you're programming in Java, you need the JDK, Java Developers Kit. So you can get that from Oracle separately if you want to use the command line stuff. But if you download Eclipse and have that should, I believe that takes care of it when you install Eclipse. If not, you'll have to go to Java. You have to go to Oracle's website separately and install the Java Developers Kit. But you would type Java C for compiler and then take the name of the source file, which is the code that we just wrote, for example. And then once you do that, if there are no syntax errors, it will result in a file named simple.class. So it has the same name as the Java file, but will result in a class. The class is the bytecode we talked about previously. Okay, so that basically has the bytecode, the Java bytecode. Remember, bytecode is basically the machine language, for a better lack of a better term. It's the machine language for the Java virtual machine. Once you have this bytecode, you just write Java with no C at the end, Java simple. Java will just cause the Java virtual machine to execute whatever the bytecode is that you specified. Do not put .class at the end, though. It will know to look for a class file, simple.class. If we were to look in the working directory, and I looked directly through Windows Explorer here, in the Lecture 3 examples, and I looked in bin and followed my way down, I would find simple.class because Eclipse already took care of this for me. I could even run this with the Java command line because Eclipse compiles it, with the Java compiler just like everything else. But in the Eclipse environment, the best way to do it is to go up to the top to the green button with the arrow on it. Assuming you have the correct file open, you just click Run, and you'll notice down in the console it will print out "Programming is great fun." That's exactly what we wanted it to print out. So let's analyze the example a little closer. If I want to, I can actually put after the package or before it, I can put this as a simple Java program, or I could write pretty much anything there. It doesn't really matter. Notice that that's a sentence. It doesn't have to have actual code in it. Past the 2 forward slashes. These 2 forward slashes indicate a comment. Okay, it's called a Java comment. It's ignored by the compiler. That means that you can write pretty much anything in here just to give yourself more information about a class or a method or a particular line of code or a variable. You can write these comments as you will and indicate to you or another developer or someone else looking at your code down the line, giving information about what the code is about. Or identifying information for the programmer. Sometimes that's used as well. This is the class header for the class simple, public class simple. And then the area inside of here is called the class's body. All right? Anything inside of here is part of the class's body. It is delimited by curly braces. You have an open curly brace and a lower curly brace, a closing curly brace. Anything within 2 curly braces is called a block of code. In this particular case, this block of code is the body of the class. In our example inside of Eclipse, everything inside of these 2 curly braces, this one and this one, including the method that's inside here, is part of this class's body. Okay? And likewise, this method that we create has a body and also has a line of code inside of it, so also delimited by curly braces. When you create the method main, you have the method header first, public static void main, string brackets args. The main method is where a Java application begins, so it's called the entry point is usually what we call this. The area between the curly braces is the body of the main method. Just like this is the body of these two, the area between these two is the body of the class. All of the actions to be completed during the main method will be between these curly braces. All right, then we put a system.out.println or print line. This is a Java statement that is executed when the program runs. All right, so it actually makes use of a class that's available to us as part of libraries of the Java API called system. And then we go to the part called out, and then print line. Print line is an actual method. This is a method that allows us to print a line of text or other data. We'll get more deep in that a little later. Comments. The lines that are comments are ignored by the compiler. The comment is an example of, the comment in this particular example is a single line comment. Okay, so you couldn't put multiple line comments yet. We haven't learned how to do that. It's pretty simple though. Class header. The class header tells the compiler things about the class, such as what other classes can use it, such as the keyword public, and that is a Java class. That's the keyword class, and then we have the name of the class, simple. So you have public class simple. Public is what we call an access specifier or access modifier. It indicates from where this particular class is accessible. Public's a Java keyword, and this access specifier, along with others, indicates where the class can be accessed from. Public means open to the public. It means anyone can access it. In any particular file, there can only be one public class. And this class, simple, has to match the name of the Java file. Class indicates, it's also a keyword, and it indicates the beginning of a class definition. Simple is what we call the class's identifier or the class's name. It is programmer defined. We decide what that name is, as long as it's a valid Java identifier. More on that later as well. Then you have the method inside of it. The curly braces, when associated with the class header, they define the scope of the class. When associated with a method, like main, like we have here, they define the scope of the method. The main method, this line must be exactly as shown in the example, except the args, the variable name, can be programmer defined. This is the line of code that the Java command will run first. Okay, so when we run it in Eclipse, this actually executes Java, so when you click it, it will run main first. It's the entry point. So the first thing it comes across, and the only thing inside of main before the program terminates or ends, is this system.out.println. Programming is great fun. It's exactly what we get when we run the program, down at the bottom for the console. Every Java application must have a main method. Every Java application must have a main method. If you've seen code for applets, that's a little bit different. We haven't covered that yet. We're not going to focus on it greatly in this class, but all Java applications, whether they are console-based or whether they have a GUI environment, at some point they have a main method. Java statements. When the program runs, the statement within main, statements within the main method will be executed. So if we look back at the previous examples that we've been looking at, you can see that there's only one line that ends with a semicolon. Okay? So exactly the same as in our code, it has a semicolon at the end. If you don't put the semicolon, it's a compiler error. Okay? This is because it is the only statement in the program, the only Java statement in the program. The rest of the code is either a comment or other Java framework code. We do not consider curly braces part of a statement. We don't consider the headers really part of a statement. A statement is an actual executed piece of code. In this case, this is the only statement inside of the method. Okay? It ends with a curly brace. Again, comments are ignored by the Java compiler, so they do not need semicolons. Other Java code elements that do not need semicolons include class headers. For example, this right here, the class header does not need a semicolon at the end. Method headers, this right here, the main method. A novice mistake is to put semicolons here and there, but you do not put semicolons at the end of a method header or a class header. You don't do that. Curly braces, part of the framework code that needs no semicolon termination. Now, if you're coming from C++, where classes are terminated by semicolon, make sure you get that out of your mind when you're dealing with Java. Java does not have semicolons at the end of curly braces, so none of that. So, as a short review, Java is a case-sensitive language. All programs must be stored in a file with a .java file extension. Comments are ignored by the compiler. A .java file may contain many classes but have only one public class. If a Java file has a public class, the class must have the same name as the file. Java applications must have a main method. For every left brace or opening brace, there must be a corresponding right brace, also called a closing brace. Okay, so back to the code. We have opening brace, closing brace. This opening brace for the class body and the closing brace. They have to match up. Statements are terminated with semicolons. Comments, class headers, method headers, and braces are not considered Java statements. Here are some special characters. This is kind of a table of special characters. It just gives you an idea of what's available to you. The double slash is for comments. Open and close parentheses is used in method headers to mark the parameter list. Like we have with main. Right here you have parameters there. You also have this right here, when we call the print line method, you have a parameter passed in. This is called a string literal, but we'll get to that in just a second. But that's passed as a parameter to print line. Notice it's delineated by the open and the closing parentheses. Okay, so parentheses are for method headers. Open and curly braces enclose a group of statements called a block of code, such as the contents of a class or method. Double quotation marks enclose a string of characters such as the message that's being printed to the screen. Okay, so right here, when we have programming is great fun, notice that those double quotes do not print in the console. The double quotes are to delineate the beginning and the end of what we call a string literal. Okay, a literal string of characters is what it is. Characters being letters, numbers, symbols, etc. It's things that we want to print to the console. Semicolon marks the end of a complete programming statement. Many of the programs that you'll write will run in the can run in a console window. So if you call it directly through the console and say Java, and then call the name of the class, it will say programming is great fun and execute the same way we have here. But in Eclipse, the console looks a little bit different for us because they've built it into the application. It's down here. But it will show us essentially the same output that we'll see in the regular console. The console window that starts a Java application is known as the standard output device. The standard input device on a computer is typically the keyboard. Java sends information to the standard output device by using a Java library stored in the standard Java library. Java classes in the standard Java library are accessed using the Java Applications Programming Interface. Okay. Also, you will also see this as Java Application Programmer Interface. It's kind of used interchangeably, and there seems to be disagreement as to what's what. It doesn't really matter. Most people just say API anyway, so it could be Applications Programmer Interface or Programming Interface. In the book, they have Programmer Interface. In the slides, they have Programming Interface, if that gives you any idea about the flexibility. I would say application, not applications, though. That I would look at as a problem with the slides. So, Application Programming Interface or Application Programmer Interface. The standard Java library is commonly referred to as the Java API, or the Java Application Programmer Interface. The previous statement, previous example, uses the line system.out.println. This line uses the system class from the standard Java library. This is a class that's available, and it contains methods and objects that perform system-level tasks. Out is an object. Okay, it's an instance of a class. It's a member of the system class and contains the methods print and println. If you don't really understand the terminology that I'm using, like class member or object, or aren't really comfortable with the word class, don't worry about it. Just kind of take it on faith and memorize the terminology as best as you can, and then you will understand it better later. But just like we developed a class, a custom class right here named Simple, someone made a class called System. And also at some point someone had made a class and created an object and then named the object Out. This is a member of the System class. And then this is the object that actually contains the print and println methods. Print and println methods actually perform the task of sending the characters to the output device. The line that we saw earlier, programming is great fun with the system.out.println, is pronounced system.out.println. Okay, because I said it already, but it's nice that they put it in words so you could know ahead of time, even if you didn't have me explaining. The value inside the parentheses will be sent to the output device. In this case, you're sending a string literal, to the standard output device, which ends up being the console. Okay, and then you can see it on the monitor. The println method places a new line character at the end of whatever is being printed out. The following lines, system.out.println, this is being printed out, on two separate lines would be printed out on two separate lines since the first statement sends a new line command to the screen. We can even go back to our code here. Programming is great fun, and then say oops, accidentally added that. System.out.println, say hi there again. All right, and then when you run it, you'll notice that we have in the console programming is great fun, then hi there again. That's because we used system.out.println and then system.out.println again. This one right here will actually move the insertion point in the console to the next line. That's why it's print line. It prints whatever you have in it, and then prints what we call a new line character, or a new line. It moves to the next line, prints whatever is over here, and then since this is a print line, it moves the insertion point to the next line, but we never see anything really except it's a blank, it's kind of a blank line on that, in that particular example. The print statement works almost identically to the print line statement. However, print statement does not put a new line character at the end of the output. For example, if we go back to our code and I take off the ln part of the print ln on both of these and run it, you'll note that it all prints on one line, and notice how they're crammed together and there's no new line between them. That's because it does not add an additional line at the end. If I change this back to ln, and then this back to ln, and run it, I'll get the output on two different lines again. For all of the previous examples, we've been printing out strings of characters. Later we're going to see that much more can be printed. There are also some special characters that you can put into the output. For example, the \n character is considered a single character even though you have to make two keystrokes. It's what we call an escape sequence that represents a new line character. Escape sequences allow the programmer to print characters that are otherwise unprintable. In other words, we don't have a single key really to represent them, or that wouldn't easily show in the code. So \n is new line, \t is tab, \b is backspace, then we have carriage return. If you want to actually print out a backslash, you have the problem that if you write a backslash inside of a string, it thinks you're going to escape something. So in order to print out an actual backslash, you have to write two backslashes. Now notice these are not the same as the comments we did earlier. Comments are two forward slashes. Two backslashes belong in a string. If we want a single quote to print out, you put \single quote. If you want a double quote, you put \double quote, because these normally have to do with strings. So if you want an apostrophe like Bob's Barbecue or something like that, you have to escape it with the backslash. So if we change these back to print, remember that print, as we see again, does not insert a new line automatically. We can, if we want to, just use print, and then at the very end of Programming is Great Fun, I'm going to put a \n. Remember, that means the new line character. If I run it now, notice it says Programming is Great Fun, hi there again, and there's no additional space at the bottom. If I put a \n again here, and then run it, I'm going to get the additional space. So see how the insertion point can go below it now? All right. So \n, I can add even more space if I want to by doing more \n's. Let's say I have 3 in a row, then that will increase the space in between Programming is Great Fun and hi there again. All right, take it back to 1, run it again, and there we go. The T, \t, causes there to be a tab. So if I want to tab in hi there again, I can put \t in front of it. Notice I'm not putting a space in between the T and the beginning of the sentence. Remember, it's considered a single character. If you put the tab and then a space, it'll have an additional space, which we didn't want. We just want the tab. So notice it's tabbed in. If I want it tabbed in twice, I can put 2 T's for tab. And it'll tab it in twice. All right. So I'm going to delete those. You can put them anywhere inside the string that you want, and it should work out fine for you. Variables and literals. This starts section 2.3. We just finished 2.2, which involved print line and print. A variable is a named storage location in the computer's memory. A literal is a value that is written into the code of the program. Programmers define the number and type of variables a program will need. Here's what I'm going to do. I'm going to go back to our project. I'm going to close simple, and inside this project right here, since we have a package already, I'm going to right-click it and say New Class, and I'm going to name this class Variable. And then notice it's part of the com.prof JPB simple because I told it to be. This one right here is going to have, again, public static void main string args, and let's have int value equals 5, system.out.print. The value is system.out.println value. And notice, if we run it, since we have this particular Java file open, not the simple.java, it assumes that this is the one we want to build and run. So we end up with the value is 5 written at the bottom. Now, why doesn't it say the value is value? Well, this is our variable right here. This is called a variable declaration. Right here is called the variable declaration. Int value. What that does is it basically reserves a memory location, gives it a name called value. It reserves a memory location that can hold an integer. This is called the data type. Okay, it indicates the type of data that this particular identifier will contain. We will get more into data types in just a little bit. Value is called the identifier of the variable. So we've got the data type and then the identifier. This part together is a programming statement, ends with a semicolon. It is called a variable declaration. The following line is known as an assignment statement, value equals 5. That assigns the value 5 to the particular memory location. These right here don't have to frighten you. 0x just indicates that a number's in what we call hexadecimal format, so it's base 16. Binary is base 2. Our number system we use as humans is base 10. Base 16 is often the format that memory locations are shown in. So that's the only reason for the 0x. Past that, it's just we've got this byte here, that byte there, or that location there, and 5 is stored in memory at that location. Okay, so in this location, the value 5 is actually stored in the variable named value. We can name the variable pretty much whatever we want as long as it's what we call a valid Java identifier. When you say system.out.print system.out.print, notice that it is not putting an extra new line character between is and the 5 that's printed on the next line in code. That's because what's written in code is not always matching what's down here. The white space we use in code, in other words, I could put a bunch of spaces here, and programmatically it will do exactly the same thing. It's not going to affect it. Okay? But this one right here, print, does not add an additional new line character at the end. The print line does, so that means the insertion point will be after. We do have the value is, and then you put the variable's name. When you apply print line to this variable, it will take the value that's stored in the variable and then print it out, like as we have here. The value is 5. If we change the value to 25 or 256 in this case, since my finger slipped, and I hit OK, it'll say now the value is 256. Okay, it's exactly what we expect. So again, a variable is nothing more than a named memory location. It's a named address in memory. You declare the variable, you assign the variable a value, and incidentally, if you wanted to, you could do this all in one fell swoop. You could write, I'm going to put it in a comment, but you could put int value equals 256, and that's both the declaration and initialization, okay, or assignment. The part that you have system.out.print has a string literal inside, like we have here. This is the string literal. A literal is an actual value, like 256 is a literal. It's an integer literal. The value is a string literal because it's in double quotes. This right here is a variable. Value is a variable. Okay, it contains the value of a literal we assigned to it earlier, but we consider this a variable. The plus operator can be used in two different ways. You're used to using it as an addition operator. That's what you do when you have math. Okay, so you have it like 6 plus 5, 7 plus 10, what have you. But it can also be used as what we call the concatenation operator, or the string concatenation operator. If either side of the plus symbol, when you write it down, is a string, the full result will be a string. So even if I put something like this, if I put system.out.println, the numbers are, and I put plus 5 plus 6, notice it is not adding these values. See how it says 56? Well, 5 plus 6 is not 56. What it's doing is since this left side is a string, immediately when it applies the plus symbol here, that becomes the concatenation operator. So it takes this 5 and converts it to a string first. Then, since everything on this side of this plus symbol is a string now, it's going to convert the 6 to a string as well. So you end up with the 5 and the 6 being treated as strings. That's why you get 56. All right. Incidentally, if you want it to perform the actual mathematics for a plus symbol, you need to put them in parentheses. Okay, then you can perform the actual math before you concatenate it, because parentheses take precedence, just like they do in math, over the plus symbol. So what is done in the parentheses will be done first. Then that value will be converted to a string when it is applied with the plus symbol here, which acts as the concatenation operator. So in this particular example with the parentheses, this plus symbol is the addition operator because it's actually performing addition upon these two integers. This plus symbol acts as a concatenation operator because it concatenates or appends the result here to the end of this string. Okay, let some of that sink in. Concatenation operator and addition operator. Concatenation is for strings, or if there's any string involved. Addition is for numbers. So, Java commands that have string literals must be treated with care. A string literal value cannot span lines in Java of a source file. So, for example, if you have this, if you have a really, really long line here, the line is too long and you keep going to other lines, you're going to get a compiler error. Instead, you have to join them with plus symbols, okay, like they do here. Notice that they're closing the double quotes here, and since we have more space to go, you type the plus symbol for concatenation, then the next line with the double quotes, and then another plus symbol for concatenation, and then finally you have an example with double quotes, or a line with double quotes at the end, and then the closing parenthesis and the semicolon to indicate the end of the print line statement. String concatenation can join various types. System.out.println, we can join a string to, and then just like I showed you a second ago, another string, and then a 5, because the integers or doubles or what have you are going to be automatically converted to a string. Alright, so the concatenation operator can be used to format complex strings. Notice that you can actually perform math in here. This is kind of convoluted, but if you look through it, the first string is just a string literal. Then you have a plus symbol that acts as the concatenation operator because it's applied to another string. Then we have the concatenation operator, and they goofed because that needs to have a double quote in it. Oops. Sorry. that should have a double quote. Let me look over it just real quick just to make sure I got it right here. Yep, looks fine. Yeah, I think they goofed in the slides. That's unfortunate, but just make note of that. See, this is why you watch class here. What the heck? It's so irritating. Okay, so the double quotes for this one will indicate a string as well, but notice this one has a new line character in it, and this is a tab. Then you have the word first equals, all inside of double quotes. Then you have a plus symbol to act as the concatenation operator. This right here, though, multiplication takes precedence and will actually be performed as a multiplication problem. Then you have a comma, concatenated again with second equals. Now notice they're doing addition here, so what did they do to do actual addition? Exactly what I showed you a minute ago. You have 6 plus 4. So it actually performs that then. Wow, they're really messing up all over the place here, because that needs a plus symbol there. Then you have another plus symbol here, a comma, a plus symbol, and then right here you have information inside of double quotes, plus symbol, a double literal, a plus symbol for concatenation, and a period. Notice that if an addition operator is also needed, it will be put in parentheses. Identifiers. Identifiers are the programmer-defined names for classes, variables, and methods. Identifiers may not be any of the Java reserved words. So that means I can't declare an integer called class. I can't do that. That's going to be an error because class is a keyword. It says invalid variable declarator. That means that it's already used. You can't name it that. It has a specific meaning. So they're called Java keywords or reserved words. A valid identifier, besides not being a keyword, has to contain or may contain only letters, A through Z lowercase or A through Z uppercase. You can have any combination of those. They can have digits 0 through 9, underscores, and in Java you can use a $sign. I highly recommend you don't use $signs because in a lot of programming languages they have very special meaning. So, and a lot of other programming languages do not allow the $sign as part of variable identifiers. So I would recommend you not do that. The first character cannot be a digit. That is the only that's the only rule in regards to using digits. If I put 1 as the first character, it's going to be an error. Okay, it's going to be very confused. But if you put A1, that is a valid identifier because the first character is a letter. If I put _1, that's a valid identifier because it's doesn't start with a number, even though it has a number in it. Identifiers are case sensitive, so this is very important in Java. We want to acknowledge that items ordered with a lowercase I and then a capital O over here is not the same as items ordered with all lowercase. Also not the same as if you had a capital I or a capital T or a capital M. Those are all different variable names, but it is not a good idea, even though it's legal as far as the syntax is concerned. It's considered bad programming style, bad programming practice to name a bunch of variables that only vary by the case. Okay, so you wouldn't want two different variables that have the same name except they only vary by the O. You don't want that to happen. Identifiers cannot include spaces. So these are the Java reserved words. These are Java reserved words. Abstract, assert, etc., etc. It goes through all the different words that are reserved and that you cannot use to make identifiers. These all have special meaning. Variable names. Variable names should be descriptive. Okay, these are identifiers. They should be descriptive. Descriptive names allow the code to be more readable. Therefore, the code is more maintainable. So if you look at these two, which of the following is more descriptive? If you have double TR equals 0.0725 or double sales tax rate. Which one's more descriptive? Well, I would say doubles the sales tax rate. Doubles a data type that indicates that we can use real numbers, so anything with a fractional part, whereas integers are only whole numbers. Again, more on that later. Sales tax rate is the name of an identifier, but it's very descriptive as to what it is. We assume it's a tax rate for sales tax, and then it has the value. This makes the program more self-documenting. Now, what does self-documenting mean? That means that the variable names, for example, or method names, are not useless. They don't have like a nonsensical names, and it helps you to document what you're doing in the very name and the very nature of these variables that you've defined. Without even using an abundance of comments, I should be able to look at this and say, oh, that's the sales tax rate. It makes sense. If I looked at TR, that could mean anything. Java naming conventions, variable names should start with a lowercase letter and then switch to the title case after. It does not necessarily, it's not necessarily the case. Some people have different opinions about this, but it is a good rule of thumb. Class names should be all what they call title case or uppercase. Like, so when we made our class variable, it has a capital V. Okay. There's more Java naming conventions available at the Java website. A general rule of thumb about naming variables and classes is that, with some exceptions, their names tend to be nouns or noun phrases. Okay? Just a general rule. We'll get to primitive data types in just a second. I'm going to take a quick break and rest my voice for a little bit, and then we'll get back to it. And then we'll finish off section 2.4 and 2.5, and we'll be done. All right. Continuing with the primitive data type. Primitive data types is section 2.4, starting on page 44 in the book. The primitive data types are built in to the Java language and are not derived from classes. So pretty much everything in Java is derived from a class, but there are 8 Java primitive data types that are not. You have byte, short, int, and long, float, double, Boolean, and char. So these are the numeric data types. Again, a data type is, again, just the type of data that a variable can hold. That's why it's called a data type, so it's no magic there. You have the byte, short, int, and long, which are the integers. Float is a 4-byte floating point number, which can hold real numbers, not just whole numbers. So integers can't have a decimal portion. So if precision is something you need, then an integer won't cut it. So you have float and double to do that. Floating point are floating point numbers, or double is a floating point number, 8-byte floating point number. It has 15 digits of accuracy, whereas float has 7 digits of accuracy. The variable declarations take the following form. You have data type, followed by the variable name, also known as the identifier. So you have byte inches would be one particular variable declaration, where byte is a data type, inches is the variable name, the identifier of the variable. Short month, int speed, long timestamp, float sales commission, double distance. These are all variable declarations. If we start with the integer data type, this includes byte, short, int, and long. These are all the different integer data types. They can hold whole numbers. Okay, these are the counting numbers and their opposites, whole numbers. 5, 10, 23, 89, etc. 0. Some of them hold, you can hold negative numbers. Integer data types cannot hold numbers that have a decimal point in them. Integers embedded in Java code are called integer literals. Like not too long ago when we said value equals 256, the 256 is an integer literal. Okay. Floating point data types. Floating point data types. These are data types that allow fractional values, such as you have 1.7. It has the fractional 0.7 part. Negative 45.316 is another floating point number. In Java, there are two data types that can represent floating point numbers. You have float and double. Float is called single precision, so it has 7 decimal points. And then double is called double precision, can hold up to 15 decimal points. You can have floating point literals as well. When floating point numbers are embedded into Java source code, they're called floating point literals. The default type for floating point literals is double. Okay, so that's the default. If you just write negative 29 point, or if you write 29.75 or 1.76, 31.51, these are considered double data types, so that is the default value. Java is a strongly typed language. Let's create the cell.java. So I'm going to close that other file we had open, variable, and I'm going to create another class. This one is going to be called sale. So sales or sale, it doesn't really matter, but sale, we'll call it sale. And in this particular instance, again, we're going to have public static void main string args. Okay, so that's an empty skeleton program for Java. Double price, tax, and total. You can declare them all on one line if you want to. You can do that separated by commas, as long as they're all the same type. So price is, say, 29.75. Tax equals 1.76. Total equals 31.51. System.out.println. We'll say that the price of the item is price. Out.println. The tax is. Now, in the book they didn't put the colons or anything, but I'm putting colons inside just to make it look different. The tax is tax. Print line. The total is total. All right. So these are all calculated apparently ahead of time. They just want to show you what it looks like when you run it. So when you run it, you get all of this data down here at the console. Price of the item is $29.75. Taxes 1.76, and then the total is 31.51. Java is a strongly typed language. That means you can't just say, oh, it's a variable and it contains, and then change what data it holds. Like some languages, you can have a variable that just you can assign it a number, and then 5 minutes later use it for a string. You can't do that in Java. You have to declare the data type and then use it as that data type. Notice that double, since double is the default value when there's a literal value like 23.5, a double value is not compatible with a float value because of its size and precision. The double is the 8 bytes. The float is 4 bytes, so that means if you try to stuff a double inside of a float, you could lose data. So Java will not let you do that. So if you declare float number and say number equals 23.5, that will return an error. However, a double can be forced into a float by appending the letter capital F or lowercase f to the end of the literal. So if I have float number and I want to assign it a value, I can say number equals 23.5 and then put an F at the end. That will work. Floating point literals. Floating point literals. Literals cannot contain embedded currency symbols or commas, so you can't write this. Say gross pay equals, $1,257. You can only have the number values, including the period. That is acceptable. The dot is fine. Floating point literals can be represented in scientific notation. So in scientific notation, we would say that 47,281.97 could be represented as 4.728197 times 10 to the fourth. Okay, since 10 to the fourth is 10,000, the 4.72, etc., times 10,000 is equal to 47,281.97. Java uses what is called E notation to represent values in scientific notation. If it finds a large value, or you want to store a large value, then you can represent it with E notation. Now notice this says E4. That corresponds to saying that the number before the E is to be multiplied by 10 to the power 4. Okay, so this is the power on the far right. It's like exponent. So this gives a couple examples of scientific notation and E notation. If you have a decimal notation number, such as 247.91, scientific notation always has one whole number in front of the, or should have one whole number in front of the dot, and then the remaining value behind the parentheses, and then, or behind the dot on the right side of the dot, and then multiplied by 10 to whatever power you're trying to increase it by. Okay, so 10 to the 2, that would cause the decimal place to move 2 this way, so we're saying that's 247.91, which is exactly what we want. E notation, not very difficult. It's the same as scientific notation. The number on the left side of the multiplication symbol is the number on the left side of the E, and the number on the right represents 10 to what power. So you ask yourself, what is the exponent that you're taking 10 to? So you just put 2. If it's 10 to the negative 4, you have negative 4 on this side. That moves the decimal point in the other direction. E6 moves the decimal point to the right. So that causes it to be 2,900,000. The Boolean data type is another data type. So we've covered integers and floating point data types that we have so far. The Boolean data type is an interesting data type because it can only have 2 possible values. Now this may seem kind of useless. Why don't we just use an integer, or why don't we use something else? But Boolean data is used so frequently in programming that we have this special type in Java to represent Boolean data. Okay, so it's basically used in logic. It's used extensively in logic and in conditional statements, which we'll get to eventually. We'll get to selection control structures and repetition or iterative control structures. We'll talk about those later in the semester when we get to control structures. But these are used extensively, so we have to get an idea of true or false. At the fundamental recall that at the fundamental machine code, we only have zeros and ones. Okay, so that basically is perfectly represented by trues and falses. Okay, so Boolean values are pervasive in computing. They're everywhere. Okay, so to use a Boolean variable, I'm going to give you an example. We'll create a file. We'll do new class. Call this true false. Public static void main string brackets args. We have Boolean. We'll just call it. I don't like their name for it because that's a data type in other languages. So I'm just going to call it my bool. I'm going to say my bool is equal to true. I'm going to say system.out.println of my bool. And I'm going to set my bool equal to false. And do system.out.println of my bool. Again, if I run this one, it's going to print true the first time and then false the second time. It's pretty much what we expect, right? Because these are, it's a Boolean data type. It only holds one of two values at any given time. The char data type, we'll see more about Boolean later in the semester. The char data type is used to store characters. Okay, so characters, a variable of the char data type can hold one character at a time. We've seen string literals already. They can hold multiple characters in double quotes, but a char holds its values in single quotes. Okay, so A, Z, even though \n has 2 keystrokes to create it, it is considered, again, it's considered a single character, just like \t, \n, \r. All of these are considered single characters. This is a new line character, okay, but it uses an escape sequence to signify what it means. Obviously, if I put n and there's no backslash in front of it, then it would think it's a lowercase n. So \n is a special indicator. Also, you could put a 1. Even though that's a number, we can represent it as character data. Also, don't confuse char literals with string literals. Char literals are enclosed in single quotes, and string literals are enclosed in double quotes. Now, a string is made up of several characters, but the way they're held in memory is slightly different. Okay. We have to pay attention to Unicode. We need to know about Unicode. Unicode, we have to know that internally the characters are stored as numbers. So ultimately everything's stored as binary. Character data in Java is stored as Unicode characters. The Unicode character set consists of 65,536, which is 2 to the 16, individual characters. This means that each character takes up 2 bytes in memory. The first 256 characters in Unicode are compatible with the ASCII character set. Okay, so for Unicode, at the lowest level, they're stored as binary numbers down here. So we have binary actually stored in memory. So in RAM or on disk, they're stored as in memory. Well, it's actually in RAM. Then the binary numbers represent these decimal values. So this number in binary right here with all the zeros and then 1000001 is actually the number 65 in decimal. Okay, remember I said there were a couple different types of systems, base number systems that we have. We have decimal, which is the one we're comfortable with as humans because, 10 fingers, 10 toes. We like counting in groups of 10. We can go from 0 to 9 in any given digit before moving over to the next digit. Hexadecimals, base 16. So that means you go from 0 to 15 in any single digit. That's why hexadecimal uses letters, because after it gets to 9. Okay, so we had a little bit of an issue for a second. The binary numbers represent these decimal values right here. And then ultimately, you have these decimal values representing the characters in Unicode. For variable assignment and initialization, in order to store a value in a variable, an assignment statement has to be used. The assignment operator is the equal sign. Okay, the operand on the left side of the assignment operator must be a variable name. You can't say 7 equals 42. That doesn't make any sense. But you have to have a variable name on the left side. The operand, okay, this is the word for the item that's on the right or left side or wherever as far as an operator is concerned. The operand on the right side must be either a literal expression that evaluates to a type that is compatible with the type of variable, or it could be a literal. Or it has to be a literal or an expression, sorry. So for example, you have months and days inside of this class initialize. You have months and days declared. Now you could do them on 2 separate lines. So you could have int month, semicolon, and then int days, semicolon. You could do them separately or on a single line. I actually prefer doing them separately, but a lot of times maybe it makes sense to do them on the same line. Then, once they've been declared, you can give them a value, so they can receive a value. Notice these are on the left side, the variable names, and then the values that you're storing in them are on the right side. Then, after they have a value, so you declare them, then they can get a value. Once they have a value, they can be used in output statements, such as the system.out.println are used in multiplication, so calculations, subtraction, whatever. If you declare the values on the same line, that is also acceptable, so they can be initialized on the same line. If you did not give them a value and then you use them, you will get an error, a syntax error, when the code compiles. So that's not kosher. It will not work. Java has 5 arithmetic operators. You have plus, minus, multiplication, division, and modulus. So addition operator, subtraction operator, multiplication operator, division, and modulus. What they mean by the type being binary, that does not mean you have to work with binary numbers all the time, or type ones and zeros all the time. What the type being binary means is that the particular operator takes two operands. So that means it has one on one side, one on the other. Okay, Java actually has some unary operators that only have one operand. It has several binary operators that take two, and it has one ternary operator, which we'll talk about later, another time. So we have total equals. This cost plus tax here is binary. The addition symbol is binary because it has cost on one side, tax on the other. When it adds these two values, it returns a value, and then that value is stored in total. Same thing with subtraction or multiplication, division. Modulus is a little bit more interesting because modulus will take the remainder. If you take a value and divide it by 5, modulus is concerned with the remainder, not the quotient. Division is concerned with the quotient. Modulus is concerned with the remainder. Okay, so modulus is also, it gives you the remainder, or what's called the residue. Okay, if it sounds kind of gross, like you need to clean something, but it's also called the residue. Arithmetic operators. There are many operators for manipulating numeric values and performing arithmetic operations. This is in section 2.5, the last section we'll be covering today. The operators that are called binary, these operators are also called, the operators that are called binary operators because they must have two operands. That's what we just went over. Each operator must have a left and a right operand. That's incorrect right here. That should be operand. Okay, I should be noting these and then complaining. But each operator has to have a left and a right operand. All right, so they do give an example called wages. I encourage you to look at that on your own. That's actually one of your things I'm going to just encourage you to look at and type it out yourself and see if you can get it to work properly. It's not very long. It's on page 56. The arithmetic operators work as one would expect. It is an error to try to divide anything by 0 unless you're Chuck Norris. Then you can do it. And when working with two integer operands, the division operator requires special attention. Division's a little tricky. In a Java program, what's the value of 1 divided by 2? Well, you might think it's 0.5, but that is not correct. The answer is simply 0. That's because you're taking two integers, so it thinks you're doing integer division. That means that the result it's going to return, regardless of what variable you're storing it in, the result it's going to return has to be an integer. So what we get here is 1 divided by 2. It'll truncate or remove any fractional part and keep the whole number part. So you have 0.5. If there's anything on this side, it gets removed, and then you keep the 0. So the solution, or the return value of 1 divided by 2, will just be 0. Precedence. Precedence is something that you need to take into consideration. Mathematical expressions can be very complex. There's a set order in which arithmetic operations will be carried out. Okay, just like please excuse my dear Aunt Sally that you learned in probably an algebra class or even way earlier, pre-algebra of some sort. The operator unary negation, that means if it's in front of a value, so for example -4, that has precedence. Then you have the multiplicative type operators, so multiplication, division, and then you have modulus, which is not in the please excuse my dear Aunt Sally. You have to consider modulus as it could be my malignant my dear malignant Aunt Sally or something. Please excuse my malignant dear Aunt Sally. There we go. Perfect. So I don't know how she's dear and malignant at the same time. But anyway, you have multiplication, division, and modulus. It's evaluated left to right. Is calculate the 4 modulus 3. That gives us a 1. So then you end up with -4 plus 1 times 13 plus 2. So then the next thing you do is the 1 times 13. That gives you 13. So then it's reduced to -4 plus 13 plus 2. -4 plus 13 is 9. Then you add 2. That's 11. All right, continuing. You can group with parentheses just like you can in regular mathematics. When the parentheses are used in the expression, the innermost parentheses are processed first. If two sets of parentheses are at the same level, they're processed left to right, just as if they were their own value, essentially. So you have to figure out that value and that value before you perform a division, for example. All right, so we're not going to go into combined assignment operators yet. We're going to wait until next week. So if you have any questions, please feel free to email me or communicate over the discussion board. I did post the slides, and I also created more discussion board for you. So if you have any questions or anything you need to discuss, please contact me and we'll talk about it. So thank you very much and have a great day.